Today we discuss about the remaining hybridizations, that is SP3 and SP3d hybridization. Okay, so first we discuss SP3 hybridization. So already we know about SP and SP2 hybridization. So here SP3 hybridization means, so in the name itself it is there one s orbital intermixing with 3 p orbitals, means the totally intermixing of one s orbital, 3 p orbitals of an atom, forming total 4 new identical orbitals. Mean total 3 are participated. That's why there is a formation of 4 new hybrid orbitals. One is 3p orbitals are involved in the hybridization. Therefore, there is a formation of 4 identical orbitals. They named as SP3 hybrid orbitals, and that will be treated as SP3 hybridization. So you can write there is an intermixing of intermixing of one s orbital. So I will write with some word big letters. Intermixing of 1s and 3 p orbitals, okay, of an atom, and how many will form? Forming, so 1 plus 3, there is a formation of 4 new identical, they are known as hybrid orbitals. So is called SP3 hybridization. And the formed hybrid orbitals treated as SP3 hybrid orbitals. Called SP3 hybrid orbitals. Okay. So how many are formed? There is 4 hybrid orbitals are formed. So we can write them. That is the combination of 1s orbital. So 3 p orbitals forming 1, 2, 3, 4. What will be the name? 4 SP3 hybrid orbitals. Means this is 1, 2, 3, 4. So like this, there is a 4 hybrid orbitals are formed. Then what will the percentage of S? What is the S character? What is the P character? So here totally 4 hybrid are there. 4 hybrid means so 100 by 4 means each one will get 25%. Though 1 unit for S, that is 25. S percent equal 25%. So then remaining, what about P? What is the percentage of P? So remaining 3 units are P. So that is 75%. Next, the 3 are arranged in which shape? Sorry, there is a 4 are formed. So the 4 formed are arranged in which shape? That is they are arranged in tetrahedral shape. Okay, tetrahedral shape. Simply it can be written as TD. Okay, tetrahedral shape. So in the tetrahedral shape, it is not a planar. So linear means it is a planar. Just remember, Linear means two bonds are in one plane. Next, triangular planar, that also a planar one. Three bonds are in one plane. But in tetrahedral, there are four bonds. All are not in one plane. Okay, there is a difference in their planes. Therefore, it is not treated as a planar. Okay, tetrahedral shape is not a planar structure. Next, in the shape, what is the angle between that adjacent orbitals? So, adjacent hybrid orbitals. What is the bond angle means? 109 degrees, 28 minutes. So, approximately it can be written as 109.5 degrees. Actually, here the total 60 degrees, just like a clock. Okay, 60 minutes equal to treated as 1 degree. Okay, this is called minutes. Okay, so 28 minutes means approximately 30 minutes. 30 minutes means also 0.5 degree. So it can be treated as a. So here important what the shape. The tetrahedral shape means see the four hybrid orbitals arranged in tetrahedral shape. So we know that the formed hybrid orbitals can be exist in different shapes. But what is the preferable shape for them? In which they will get more distance and less repulsion forces. Okay. If we can form any four. For example, in the SP2 hybridization in earlier class we saw that the three hybrid orbitals are formed. The three are arranged in triangular planar because that is only the shape. They are getting more distance compared to the all other shapes. At 3 unnappudu the maximum distance they obtain only by getting triangular planar. In the same way, there is a four hybrid orbitals are formed. These four hybrid orbitals get less repulsion, more distance by getting nothing but by existing only in a tetrahedral shape only. Okay, that's why they involve in tetrahedral shape. So the tetrahedral shape is so like this. So this is 1, 2. So at last you draw the small lobes. Okay, these are four SP3 hybrid orbitals. This is the first one, the second one, third one. This fourth one is so it is appearing small in size compared to others. Just because we draw it like that because it is not in this 1, 2, 3 are present in one plane. The fourth one is present in the backside plane. Okay, so that's why it is we draw it slightly. Okay, so these are the four SP3 hybrid orbitals. Now we see an example for it. Okay. Example, we take methane. Okay, methane. What is the formula of methane? CH4. And we know that only central atom. Okay, in any molecule, only central atom involves in hybridization. So, can you guess what is the central atom in methane? In methane, so there is only one carbon, 4 hydrogens. Obviously, the central atom is carbon. Central atom is carbon. So what is the carbon hybridization normally? So what is the atomic number? Carbon 6. It has 6 electrons. 1s2, 2s2, 2px, 2py, 2pz. Okay. 6 electrons means by putting 1 and 1. Now there is 2 valency. So what is the valency shell here? Second is the valency shell. The highest number is treated as valency shell. Here this is the second shell, 1, 2, 3, 4 electrons are present. But the pz is, it is 0. There is no electron is present in P0. Means there is a possibility of excitation. Okay, in excitation this electron will transfers here. So first electron, only one electron transfer, that's why it is written as first excited state. Okay, the first excited state, what is the configuration? 1:2, so sorry, one electron shifted here, so now it becomes to px1, py1, pz1. Okay, now at this position, at this first excited state, 1 s orbital, 3 p orbitals, that is px, py, pz of carbon and s orbital of that carbon combine together forming 4 sp3 hybrid orbitals. Okay, these 4 are ready for bond formation or not? How can you say that? Because all are having unpaired electrons. So after they involved in the hybridization, there is 4 sp3 hybrid orbitals are formed. That 4 also contain same unpaired electron, because in rules, in the hybridization rules, we know that the electron arrangement before the hybridization and after the hybridization is exactly same. Means before the hybridization there is 4 unpaired electrons are there. Therefore after the hybridization the formed 4 sp3 hybrid orbitals are also contain 1 unpaired electrons each. Next, what are the side atoms? Side atoms are hydrogens. Okay, so how many hydrogens are there? 4 hydrogens. So hydrogen 1s1. So such that how many hydrogens are there? 4 hydrogens are there. Here how many sp3s are there? There is 4 sp3s are there ready for bond formation. So one sp3 overlaps with this s, one overlaps with this s, one overlaps with this s, one overlaps with this s. Now there is a formation of 4 sp3s bonds. Now we write the diagram. So you got this point, 4 sp3 hybrid orbitals overlaps with s orbitals of 4 hydrogen atoms. These are also ready for bond formation as they are contain 1 electron. These 4 sp3 are also having 1 each electrons. They are overlapping. So what is the overlapping? sp3s, 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 sp3s. So we can draw so this is one smaller one. Okay, so these are 4 sp3 hybrid orbitals of carbon. Next, draw the small lobes. Okay, these are 4 sp3s. sp3, 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 sp3. You need to draw with somewhat bigger size. So all are having unpaired electron. All are having unpaired electron. So these are all sp3 hybrid orbitals now overlaps with the s orbitals of 4 hydrogens. Okay, s orbitals of 4 hydrogens. This is s orbital. Okay. All s orbitals are also having unpaired electrons. Okay, just take them carefully because they are looking very small in size. So these are all s orbitals of hydrogen. Now what is the overlapping? Overlapping of sp3 of carbon with s orbital of hydrogen. So it can be written as carbon having one hydrogen bond, other hydrogen, This is a somewhat cross with small line indicates that backside it is present. Okay, so what are the bonds? There are 4 sigma bonds. It consists of 4 sigma sp3s bonds. So what is the nature of bonds means 4 sigma sp3s bonds. How you named that? Because the overlapping of sp3 takes place with s, such that so like that there is a 4 are present. So 1, 2, 3, 4, 4 sp3s bonds are present. 4 are sigma bonds. So what is the shape? The shape. We know that sp3 hybridization involves shape is tetrahedral shape. So bond angle. So that 4 bonds are present. Here bond angle means the angle between any 2 adjacent bonds. Any 2 adjacent bond is called its bond angle. The shape is exactly tetrahedral. What is the bond angle? 109 degrees 28 minutes. So you have to remember, if a molecule involves an sp3 hybridization with 4 bonds, a molecule involves sp3 hybridization having 4 bonds, it must possess a tetrahedral shape with bond angle 109 degrees 28 minutes only. Okay. So take the diagrams clearly. Okay, if you are unable to see the diagram perfectly, just take a screenshot. Afterwards you take the diagram perfectly just by zooming it. Okay. Next we see the other hybridization. Today we see one more hybridization, that is SP3d hybridization. SP3d hybridization. So obviously we can write the definition. The simple, that is intermixing of what? One s orbital, 3 p orbitals and 1 d orbital. Okay. One d orbital forming total, how many will form? The 1, 3, 1. That's totally 5. The forming 5 new identical hybrid orbitals. Okay, forming 5 new, because 5 more form involved. That's why obviously 5 new identical orbitals will form. The new identical hybrid orbitals is called SP3d hybridization. So obviously the former hybrid orbitals are called SP3 hybrid orbitals. Okay, so next important, so we add them in general way. One is 3 p orbitals, 1 d orbitals, forming 5 SP3d hybrid orbitals. Okay, so like this 1, So no need to write separately. The 5 sp3 hybrid orbitals are formed. So, okay, let's wait. So there is a formation of 5 sp3 hybrid orbitals. Okay, now what is the S percentage? Okay, what is the S character? So here totally 5 are formed. 5 are formed means the total percentage for 100. So 100 divided by 5 means 20. 1 unit is having 20. S is having 1 unit. That is 20%. So what is the P? P is having 3 units. Total 5 units. 100 divided 5 means 20. Each unit is having 20%. So P or 3 units are present for P orbital, P character, 20, 20, 20, 60%. Then what is D? D also 1 unit. So that is also 20%. Means S character 20%, P character 60%, D character 20%. Then what is the shape? Okay, what is the shape of the arrangement? What is the shape of SP3d hybrid orbitals arrangement? So generally it is given that the shape of sp3 hybrid orbitals is the shape of sp3, sp2 like that. But actually it is not the shape of sp2, shape of not sp3. The shape of arrangement of these sp3d orbitals. Okay, the shape obtained, the shape in which these 5 sp3d hybrid orbitals arranged is. So the 5 are there. The shape in which they will get more distance and less repulsion is trigonal bipyramid. Okay, trigonal bipyramid. From now onwards we write it as TBP, trigonal bipyramidal structure. Shape, the shape is trigonal bipyramid. So what is the angle between? What is the angle between that hybrid orbitals? So here the main bond angle is 120 degrees and 90 degrees. So there is two type of angles are present, and there is also, we can guess one other also, but it is not given officially. Therefore we put it in brackets. That is 180 degrees. So what is that shape? We see now. So 5 are formed. Okay. So first exactly a triangle. Okay. So it is just like a ceiling fan. Just like ceiling fan. Okay. That there are 3 wings are present. Okay, 3 wings are present. Like for example, if you observe the ceiling fan, 3 wings are like this. Like in the 3 wings, above one rod is present. Okay, in that one place, in that the rod place, one orbital is there. Exactly opposite to the rod. Okay, and if a fan man 3 wings తీసుకున్నప్పుడు ఆ rod place లో ఆ 3 wings place లో 3, they are all in one plane. So ఆ 3 wings ఒకటే plane లో ఉంటాయి. Okay, so a 3 wings ki one rod is fixed in above the plane. Okay, so a pi plane lo manaki, so daniki perpendicular ga one rod is there. So a rod place lo one sp3d. So a rod ki opposite downwards lo one sp3d. Okay, so it is the one is above this plane, the another is below that plane. So here we can observe that total 5 orbitals are present. So here So these three are in one plane. Okay, these three are in one plane. So this is in one plane. Okay, means this triangle, this is exactly perpendicular to each other. So it can be written like this. So this is a triangle. So this is one orbital, this is one orbital, this is one orbital. These three are just like the fan wings. So one is above this, so one is below this. Okay, so why I am drawing again, this means to explain the bond angle. So there is a two bond angles mainly given, so that just leave that above this vertical bonds. So above the bond, above the plane, below the plane, just leave it. Just see the only triangle. So each triangle has a, so what is the bond angle between the triangles? So that is 120 degrees. Okay, and a fan wings lo 1 by 1 ki unna angle 120 degrees. Next, what is the fan rod? A fan rod ki a fan wing ki. Okay, so this is the fan rod. Ila wings untayi 1, 2, 3 directions, so 3 wings untayi. A fan rod ki wings ki what is the bond angle? So this is a rod. So rod ila unti it wing, ikkada wing, ikkada wing itla untayi. Means they are exactly 90 degrees. Okay, means so the 90 degrees is like this. Above rod ki wing ki, so that is 90 degrees is present. So these are the official bond angles given for SP trigonal bipedal structure, and we can guess one another bond angle, that is the total triangular plane ki above the one rod imagination. Same exactly opposite one another bond. So now the bond angle between these two, we can guess it as 180 degrees. Okay, so therefore there is a possibility of mainly two bond angles, that is 120 degrees, 90 degrees officially, and we can observe the one more bond angle, that is 180, which is placed the bonds, nothing but the hybrid orbitals present above that plane and below that plane. Okay, now we see the example for it. The example is phosphorus penta pentachloride. Okay, so PCl5. So in the name, obviously we can guess what is the central atom. The central atom is phosphorus. What is the phosphorus? 15. What is the configuration? We must know the configuration. Without knowing configurations, don't try to read this topic. Okay. So 15 means I think it's a PX1, PY1, PZ1. There is a 3D0 is also present. So it should form 5 bonds. Okay, it should form 5 bonds, and in valency shell there is 3s2, 1, 1, 1. So it needs 5 unpaired electrons. So there is a possibility for exciting. So excitation is possible. So therefore it undergoes first excitation. How it becomes in first excited state? The electron from one electron from this orbital shifted to 3D. So the 3D orbital starts from, so d orbital starts from third shell only. In second shell there is no presence of d orbital or d subshell. Indeed there is the 5 boxes are there, so no need to write that 5 boxes, only 1 electron. Now in this first excited state, one s orbital, these 3 p orbitals, 1 d orbital. So 3s orbital, 3px, 3py, 3pz orbital and 3d orbital. These are the names of orbitals. Okay. The 5 involves hybridization and 5 are formed 5 SP3d hybrid orbitals. Now all these are ready for bond formation or not? Exactly, they are ready for bond formation as they have 5 unpaired electrons. Okay. The 5 are having 1 unpaired electrons each. Okay. So what is the chlorine position? So how many chlorines are there? There is a 5 chlorines are there, the side atoms. The chlorine condition is like this. So like this, how many chlorines are present? There is 5 chlorines are present. So no need to write that 5, okay, because they are lengthy one. So I am not writing the 5 chlorines. Just remember that 5 chlorines are present. That 5 chlorines pz orbital overlaps with 5 different sp3 orbitals of phosphorus. Okay, forming 5 sigma bonds. Okay, now let's see the bonds. So it involves, there is a 5 so these are 5 sp3d hybrid orbitals. All are having unpaired electrons, mean all are ready for bond formation. All involves in overlapping with the p orbitals of pure p orbitals of 5 chlorines. Okay, so that 5 chlorines p orbitals are also having unpaired electrons. So this is the diagram. So these 5 sp3d hybrid orbitals of 5 hybrid orbitals of phosphorus. Okay, so this is in this triangle 3 chlorines. Above the triangle 1 chlorine, below the triangle 1 chlorine. So this is the shape of a phosphorus pentachloride. So generally it can be written as by taking the 2. Okay. Okay. Cl, and it is also given like this also. Three chlorines. One is above that triangle plane over, one is below that plane. Okay, so we know that bond angles. So there is we know that in this triangle, within triangle there is a 120 degrees present, and above the plane in the triangle, above the plane in the triangle each is having a 90 degrees, and above the plane, below the plane, unofficially it is given 180 degrees. And the first thing is what is the shape? Okay, just remember Just remember that if any molecule, if the central atom undergoes SP3d hybridization with 5 bonds, SP3d hybridization with 5 bonds. Already we know that 5 SP3d are formed, but in some cases what happens, some are not involving the bond formation. So I am saying the fixed shape if the 5 SP3d hybrid orbitals involved in the bond formation. That is if in a molecule the central atom involves SP3d hybridization with 5 bonds, it must be exist in a trigonal bipyramidal shape with these bond angles. Trigonal bipyramid. Okay, so this is a SP3d hybridization. Okay, next class we see the remaining hybridizations. Okay, you must practice the diagrams without seeing that. Okay, so diagrams are very important, and it is also important to know the what type of bonds are formed. So here what type of bonds are formed? All are direct overlapping, that is end on end overlapping. So it is straight overlapping here. It is straight overlapping. The straight overlapping is called what? Sigma bond. So there is how many sigma bonds? So 1, 2, 3, 4, 5 sigma bonds. So what are the 5 sigma bonds? They are formed by the overlapping of which orbitals? So that is how many sigma bonds? The 5 sigma bonds. They are formed by the overlapping of SP3d and S. So they treated as 5 SP3d P bonds. Okay.